Good evening, everyone. Right now, few students are joining, so we'll wait for 1 or 2 minutes, then we'll start this lecture. Okay, so good evening, everyone. Welcome to the course of tutorial session of the course of Introduction to Robotics. So, I'm Abhishek Thakur from IIT Hyderabad, a Prime Minister Research Fellow at IIT Hyderabad. So, this course is taken by Professor Asokan T and two more professors. Balaraman and Professor Krishna from IIT Madras. The course starting date was 24th July and the course will end on 13th October. Am I audible? So, am I audible? Can anyone confirm? Okay, thank you. So, the exam date is 28th October. So, course registration has been also extended for a week. So, you can register if you have not, or if your friends want to register, then you can. So basically in this tutorial session, we'll solve problems based on the lectures taken by the professor on NPTEL portal, which was uploaded on NPTEL portal for the week 1. So this tutorial session by me will be organized on every Tuesday between 7 to 9 p.m. and the link will be mailed by NPTEL also, and I have written in this slide. So basically in the week 1, in the NPTEL portal, basically it was taught about the rotation and translation matrix. So we'll first see what is the use of this rotation and translation matrix in field of robotics. So nowadays, I guess like you must have work or like you must have read some of the paper based on autonomous vehicle. So in autonomous vehicle, you can see that there are multiple sensors. Let's take an example of autonomous vehicle is also one kind of robotics. So let's take autonomous vehicle. So in autonomous vehicle, there are multiple sensors used. One of them, like the most important sensors are LiDAR, camera, radar, GPS, and etc. So why are we studying about this transformation matrix? Like this transformation matrix, which consists of rotational matrix, and translational matrix. What is the use of this? Like, let's suppose these are the four sensor, one, two, three, four. So all have its independent coordinate axis, separate coordinate axis. All this sensor have. Also, let's suppose this is our vehicle. So maybe LiDAR is mounted here. Camera must be mounted in the front. And let's suppose GPS is here. Another sensor, let's suppose. So for like taking action, depending on the perception, let's suppose the obstacle is detected or some navigation to be like planned. And in that case, each sensor should be transformed to the vehicle common axis first. So mostly, let's suppose this is the rear wheel. So we take this is the center of the rear wheel as a vehicle common coordinate axis. So this I'm just briefing so that like what is the use of this what we have studied, the rotational and translational parameter. So what happened now with with respect to this coordinate axis, all LiDAR have its own coordinate axis, x, y, and z at the top. GPS have its own coordinate axis. So all are transformed with respect to the common coordinate axis. So for that, this transformational matrix is required. We will go into, I will study more about the examples of the real world scenario in future. But now we will solve some of the questions based on the week one lecture. And also like, let's suppose this is our first coordinate axis, F1, F2, and F3. And there is another coordinate axis. So by using this, let me admit all. So by using this coordinate transformation, what we are doing, we are transforming the one coordinate onto the another. This can be done by using rotational and translational because here you can see the center of the both the frame is, it is translated and rotated, and then it can be projected onto the frame F. In the same way, what we can do, like for all the sensors here, it have their own coordinate frame. So all can be translated, or rotation is required also because the GPS and LiDAR don't have the same heading. So the translation and rotation is required to transform all these onto the vehicle common coordinate axis. So the transformation matrix P, that is a 4 cross 4 matrix, it consists of rotational matrix, that is of 3 cross 3, translational matrix, that is 3 cross 1, and then after that the scaling factor sigma, and this anti is 0, that is 0, 0, 0. So in this question, like it is asking if a physical point in three-dimensional space is expressed in terms of its homogeneous coordinates and we want to change from one coordinate frame to another, we use a 4 cross 4 homogeneous transformation matrix given as this. What you have studied in the lecture also. So where R is the homogeneous transformation matrix T, where R in the homogeneous transformation matrix T represents a, like they are asking in this question, what is this R? So this R is a rotation matrix, and that is of dimension of rotation matrix is 3 cross 3. So option A is the correct option. If you have any doubt, then you can ask in the chat box also, and also you can unmute yourself and ask in between. We'll also read about this rotation matrix after that. So now coming to the question 2. In this question, it is asking consider a three-dimensional fixed orthonormal coordinate frame. F is equal to F1, F2. The F have three axes, that is F1, F2, and F3. All are perpendicular to each other because it is written orthonormal and have the unit dimension. And the mobile coordinate frame M that have axes M1, M2, M3 that are aligned such that two frames are having same origin and F1, F2, F3 are along the same direction with M1, M2, M3. So in this question, it is saying the frame F have F1, F2, F3. Frame M have M1, M2, M3 that are aligned such that two frames have same origin. So this M frame have also the same origin and it is aligned with M1 is aligned with F1, M2 is aligned with F2 and M3 is aligned with M3. So now they are asking the coordinate transformation matrix is. So you can also reply the answer in the chat box. So let me see what answers. Yeah, correct. Identity matrix. How it will be identity matrix? We know that coordinate transform matrix A is our coordinate transformation matrix and this is given as dot product of F1 M1, F1 M2, F1 M3, F2 M1, F2 M2 and F2 M3, F3 dot M1, F3 dot M2. and F- So now you can see the dot products gives us, let's suppose A dot B is there, then it will become AB cos theta. Okay. So now you see in between F1 and M1, the theta is 0 degree and cos 0 is 1 and cos 90 is 0. So F1 dot M2, like F1 and M2 have 90 degree like the gap, the phase between the F1 and M2 is 90 degree and F1 and M3 is 90 degree. So here the cos 90 will become 0, and these are orthonormal as mm, described here. So the magnitude will be 1. So 1 dot 1 is 1 and cos 0 is 1. So it will become 1, 0, 0, 0. Now you can see F2, M2, they are aligning properly on the same axis. So the cos 0 will become 1 again. And F3, M3 is aligned. So it will become 0, 0, 1. So this is the identity matrix. So option C is the correct option. Any doubt in this question? Okay. If no doubt, then we'll move on to the next question. Now in this question, it is given, consider a three-dimensional fixed orthonormal coordinate frame F, that is F1, F2, F3, and a mobile coordinate frame M1, M2, M3. The coordinate transformation between F and M from figure 1 will be. Please explain first question. Last of this first question, okay, I can explain now. Basically, for transforming one frame onto the another coordinate frame, we need to rotate that frame or translate it. So, the combination of rotational and translational parameter can be combinedly given by the transformation matrix T. And T is equal to R, that is 3 cross 3. Here I can write, I can expand this. Our T is a 4 cross 4 matrix. So this is R11, R12, R13, R21, R22, R23, R31, R32, R33. And P is a translational matrix, that is translation in X, Tx, Ty, Tz. And here it is 0. And the sigma, the scaling factor will be 1. So this is our transformation matrix to transform one coordinate frame onto the another. So here R is this part. So this is the rotation matrix. It is asking the dimension of rotation matrix. So that will be 3 cross 3. So now we will solve this question. Here we have written our coordinate transform matrix A as this. We'll use this coordinate transform matrix A to solve this question. A is equal to, our fixed matrix have F1, F2, F3. Yeah, someone have given the answer 001, 100, 010. Yeah, it's correct. So here F3 M1, F3 M2, and F3 dot M3. M is the mobile coordinate frame, so it can move with respect to the F. So here you can see the angle between F1 and M1, that is 90 degree. So cos 90, the dot product will be 0. And F1 and M3 are aligned. So this will be also 0 and this will be 1. Now when you see with respect to F2, F2 is aligned with M1, so it will become 1, and other two are at the angle of 90 degrees, so it will become 0, 0. In F3 is aligned with M2, so it will become 0, 1, 0. So the coordinate transformation matrix between F and M from the given figure will be this A, and A is the option B, that is the correct option in this case. Actually, the rotation matrix, what we have studied above, that is the combination of yaw, pitch, and roll matrix. So we will see what is this. So a 3D body can be rotated about 3 axes, and that is referred to as yaw, pitch, and roll. So first of all is yaw. Yaw is the rotation in the counterclockwise direction about the z axis. So let's suppose this is our x-axis, this is our y-axis, and this is our z-axis. So any rotation with about the z-axis is known as yaw. So in this, uh, let's suppose z is coming out of this paper or out of this screen, and x and y is the screen plane. So in this case, anything which is rotated in xy plane, so this is about z-axis, x dash and y dash. So this rotation is known as yaw. Let's suppose this rotation is about of 30 degree. So here our alpha is equal to 30 degree. Okay. And the matrix given, the rotation matrix given by rotating the axis about z axis is rz alpha, that is cos alpha. You can see this matrix here. This matrix can also be we can also find this matrix using this transformation matrix formula A by taking the dot product. Okay, as you can see here that Z is common. Now when you do, let's suppose the green one is the mobile axis, then Z, you can see that Z is common in both this thing. So F3 dot, here you can see the formula F3 dot M3. So this will become cos 0, so that will become 1. Here I will again write it, the formula, so that you won't get confused. That is F1 dot M1, F2 dot M2, F1 dot M2, F1 dot M3. So here you can see there are two coordinate frame here, one in the green color, one in the black color, and both are orthonormal. So when you do dot product, you just need to do the A dot B cos theta. Theta is the angle between them. So here A is equal to, let's suppose this is our F1, F2, F3, and this is M1, M2, M3. So F1 dot M1 have cos alpha value here, and then when you do F1 dot M2, that will be 90 plus 30 degree. So 90 plus alpha degree. So cos 90 plus alpha is minus of sine alpha, and this M1 and F3, that is at 90 degree. Angle between them is 90 degrees, so call that will be 0. And again, then F2 dot, here you can see F2 dot M1, that will become again sine alpha, because, and here F2 dot M2, F2 is this and M2 is this will become cos alpha. Then again, these all are at angle of 90 degrees, so it will become 0, 0, and F3 and M3 is aligned, so it will become 1. Angle between them is 0 degrees, so it will become 1. So any doubt in this? Like how we have found the rotation matrix, that is a yaw matrix. Okay. Similarly, we can find the rotation about the y-axis, that is known as the pitch matrix, that is given as Ry beta, and roll is the rotation about the x-axis. Okay. So this is our x, this is our y, and z is coming out of the screen. So the rotation along the x-axis is known as roll. Rotation along the, it is in counterclockwise direction. Rotation along the y-axis is known as pitch, and rotation along the z-axis is known as yaw. So when you find all these Rz alpha, Ry beta, Rx gamma, the rotation matrix R is given as the product of yaw matrix, pitch matrix, and roll matrix. So when you do all this multiplication, all the three matrices we have found here, 1, 2, and 3. So by multiplying 1, 2, 3, you will get this. Okay. And our rotation matrix is orthonormal. So the modulus of like each column, when you do, like when you find the modulus of each column, you will get the magnitude as 1. Here you can find also, you take cos alpha, cos beta, sin alpha, cos beta, minus sin beta, square it, take the under root, you will get value as 1. So the next question is the modulus of each column of rotation matrix is. So here you can take, let's suppose we take the column 1. This is our column 1. So that is cos alpha, cos beta, sin alpha, cos beta, and minus sin beta. When you do the square of this, you will get, here cos square beta will be common. Cos square alpha plus sin square alpha plus sin square beta. So this term will lead to 1. So here you will get cos square beta plus sin square beta. So this is equal to 1. So the modulus of each columns of the rotation matrix is 1. Any doubt in this? So these are the properties of rotation matrix. And the determinant of the rotation matrix, that will also 1. That will be also 1, because when you do the determinant of any orthonormal matrix, it becomes 1. Okay. So the next question is the inverse of the rotation matrix R. So the inverse of the rotation matrix R will become transpose of R. Okay, because this is orthonormal matrix. For orthonormal matrix, the inverse of the matrix is the transpose of that matrix. Like you can do, you have this R, you take R transpose, and after that you do R dot R transpose, you will get the identity matrix that is I. Okay, so R transpose is the inverse of R. So this was the sum of the properties of this rotation matrix. So now we'll solve one question. So in this question, like till now, any doubt, then you can ask. Okay, no doubt, then we'll solve this question. A frame B is rotated by 60 degree about z-axis of A. Okay, let's suppose there is a frame A and z-axis is coming out of the paper. This is our frame A and B is rotated 60 degree about z-axis. So if it is rotated 60 degree, then earlier, let's suppose this was the frame B. After rotation, it will become, okay, so this theta is equal to 60 degree. This is frame B and the red one is the frame A. So if the coordinate of point P in frame B has the coordinate 1 comma 1 comma 1, so what is its coordinate in frame A? Okay, so the position in B is 1 comma 1 comma 1. So it is asking what is the coordinate in frame A. So for this kind of question, first what we do, we find the coordinate transformation matrix. After that, we multiply with the position. Like here, we have to find the coordinate in frame A. So PA is equal to A into PB. Okay. So, so in this case, our A is equal to, now it is rotated about Z axis. So this term will be 0, 0, 1 and 0, 0. Here you can see we have already found this. So when we rotate along the Z axis, this will be the rotational matrix that is cos alpha in the first and third term. So cos alpha is 60 degrees. So cos 60 degree is, what is the value of cos 60 degree? That will be 1 by 2. And the above one is minus sine alpha, that is minus root 3 by 2. This will be root 3 by 2. This you can also find using the dot product or by taking the dot product of two coordinate frames. But now we have done lots of time, so we can directly remember if it is rotated about z axis, then take the third term as 1, the remaining are 0, 0 because this uh, about the z axis, all other x and y axis at 90 degree. So dot product will be 0 here. And you can easily solve, and I have already solved before. So you can refer to this slide. So now what we will do, we'll find the position in frame A, that is equal to, we'll multiply this 1 by 2 minus root 3 by 2, 0, root 3 by 2, 1 by 2, 0, 0, 0, 1. And the position in B is 1, 1, 1. So when you multiply, you will get position in A is equal to 1 minus root 3 by 2. 1 by 2 minus root 3 by 2. This term is 0 into 1 is 0. Root 3 by 2 plus 1 by 2. That will be 1 plus root 3 by 2. 0, 0, 1, 1, 1, 1. So this will be 1 into 1. So root 3 is 1.7 something. So this will become 1 minus 1.7, that is minus 0.7 by 2. 2.7 by 2, 1. So the option is like this is 0.732 root 3. So when you divide it, you will get minus 0.366, 1.366 and 1. So the correct option is option A. Any doubt in this question? If you have any doubt, then either you can unmute or you can ask in the chat box. So we'll move on to the next question now. So in the next question, that is also a frame B. It is also on the rotation of frame. Same question, same kind of question. So here a frame B is rotated by 30 degree about Z axis of A. Let's draw frame A first. This is frame A. So B is rotated 30 degree about Z. So this is theta is equal to 30 degree. It is rotated about Z axis, so Z will align in both the frame. And it is again rotated by 60 degree about X axis of A. Okay. So now it is rotated about 60 degree of X axis of A in the counterclockwise direction. So the next part will be like this. So now the X will remain there only. This Z will come as 60 degree here. True. This X will be here at 30 degree only because it is rotated about the X axis. And this Y and Z is rotated by 60 degree. So this will rotate in this direction 60 degree, and this will also rotate in this direction by 60 degree. So just you draw the figure. Imagine in your mind. I am little bad at drawing. So now it is asking the combined rotation matrix is. So the first rotation is along the Z axis, that is 30 degree, and the second rotation is along the X axis, that is 60 degree. So the combined rotation matrix is the multiplication of these two. So the correct option is option A, that is R X 60 and R Z 30. So any doubt in this?
Excuse me, sir.
Yes.
Sir, D is rotated 30 degree about X is A line is X, no, sir? Z.
That is Z, about Z axis. So it will keep the Z axis and it will rotate in the plane of XY. Like that.
This 60 degree is rotated in the plane of
In the plane of is about X axis. So it will keep the X axis and it will rotate in the ZY plane.
ZY.
Okay.
So can you tell me the clarification that whenever we are rotating with respect to x-axis means, then it will be in the plane of x and y.
No, I am telling, let's suppose all the three cases. When it is rotating along the x-axis, then this x-axis will be fixed here and the rotation will be in y and z.
Y and z will be the plane.
Yes, sir. Yes. So let's suppose this 30 degrees rotated about x-axis. So this will be the rotation.
Okay.
And if let's suppose if it is rotated along y-axis, this is rotation along x, and this is also known as roll. This is also called as roll. When it is rotated along y-axis, then y will be fixed here. And let's suppose it rotated at 30 degree in x and z plane. So this will be theta. Theta is equal to 30 here. So rotation along y.
That's
This is known as pitch.
that's
Okay. Now it is similar kind of question what we have studied here in this question. Like a frame B is rotated by 60 degree. In this also it is rotated by 60 degree about z axis of A. And then only one extra part is added here that it is translated by 2 to 2. So now what will be the coordinate of point P in the frame B? No, sorry. If coordinate of point P is in frame B is 111, then what will be the coordinate of that point in frame A? So the coordinate in frame A is equal to transformation matrix into coordinate in point B. Now here the transformation matrix will contain both rotational and translational. Okay. So this will become R11, R12, R13, PX, R21, R22, R23, TY. Then it will become R31. Actually, someone tries to join. That's why I take time in between to admit them. R32, R33, PZ. And this is a 4 cross 4 matrix. This is 0, 0, 0, and 1. Okay. So now the rotation is 60 degree about z axis. So the rotational parameters are same. So we can directly take this as a rotation matrix. That is from previous question we can take 1 by 2 root 3 by 2. Was it like that? Yeah, 1 by 2 minus root 3 by 2, root 3 by 2, 1 by 2, 0, 0, 1, 0. Now the translational parameter, that is, it is translated by two units in each axis, like in x, y, z. So tx will be also 2, ty will be 2, and tz will be 2. So this is our transformation matrix T. Now when you multiply, so the position in frame A is equal to What is in the B? That is 1, 1, 1. So it will become 1 by 2 minus 1 minus root 3 by 2, 1 minus root 3 by 2. This will become plus 2. So this will become how much? 1 minus root 3 by 2. We have calculated. So minus 0.366. So it will become minus 0.366 plus 2. And the second term will become root 3 plus 1 by 2. That is 1.366 plus 2. And third term will become 1 plus 2. So here you can see this PA is 1.63 something will come. This will become 3.3663. So the position in A is, the correct option is 1.634, 3.366 and 3. So this is the option A is the correct in this question. So do you have any doubt? See here, there, yeah,
Sir, matrix, how did you come to know it is 4 cross 4, sir?
because see, for like when there is only the rotational parameter, so in that case, what we do here, we directly multiply PA is equal to A into PB. Now, A is the rotational matrix that is 3 cross 3. Okay. So now this is the case only when rotation is there. Now when translation is there, then one more column will come. That is the translation in Tx, Ty, Tz. And this one is the sigma, that is the scaling factor. Generally it is 1 in almost all the cases, what we are studying now. And this is the perspective that is kept as 0. So that multiplication can be done. So you can see here, in when there is a translation, the answer is same. You can see minus 0.366, 1.366, 1. In this case also the answer is same only. Now the extra term added is plus 2. That is the translation in the x, y and z. Okay. So using the rotation and translational parameter, this matrix became 4 cross 4. Okay. When there is only rotational parameter, then it will be 3 cross 3. When there is translational parameter also along with rotational, it will be 4 cross 4.
Always it is fixed, sir. Whenever we are having a transformation in the matrix along with rotation, means it will be 4 cross 4 only.
You can take always as 4 cross 4. Like you take this as 4 cross 4. Let's suppose there is no translation parameter. Then this term will lead to 0. Okay.
Okay.
Sorry, this scaling factor will be 1 only. So this term will lead to 0. Now you multiply, you will get the same answer in the previous question.
3 cross 3 matrix.
The same answer you will get.
Okay.
So you can assume this as the 4 cross 4 standard matrix, which consists of rotational parameter and translational parameter. And this is sigma as 1 here. Now when there is no translational parameter, you keep this as 0. If there is translation, then you keep that value. Like here, the translation is 2 units in XYZ direction.
Sir, is that always the coordinate is to be fixed for x, y, z only 3 or it can increase? 3 dimensional only?
Yeah, it can increase. Either you can do in two-dimensional transformation also you can do.
Okay.
Even
Which
for
factor is
you can increase the dimension also. That will be more complex process. Here you can see for two-dimensional, the rotation is like this, and
okay.
here for two-dimensional, this is the transformation matrix. So this consists of only 3 cross 3. So here, this is our rotational matrix. TXTY is the translational parameter because the translation can be done in only X and Y axis. Rotation can be also done in X and Y. That's why it is rotation is 2 cross 2. Translation is 2 cross 1 in this case.
Okay, sorry. Based on the dimensions, the matrix size
The
will increase.
transformation matrix size will increase or decrease.
Means if it is two dimensional, it will be 2 cross 2. Three dimensional means 3 cross 3. Four dimensional means it will be 4 cross 4.
Yeah, for the rotational matrix.
Can we fix that, no, sir? Based on the dimension, only
Hmm.
the matrix size will be, we can
Yes.
adjust.
Like let's suppose there is a four-dimensional.
Compulsory rotational.
Rotational will be 4 cross 4 and translational will be also 4 cross 1.
Okay, sir.
Okay, and in that you can add just wait a minute. Okay, so we'll move on to the next question. So the scale parameter of a homogeneous transformation matrix is 1, as we have seen in the matrix here. We have kept sigma is equal to 1 here. And the perspective part of homogeneous transformation matrix is kept as 0, 0, 0. Here we have kept. Okay, so now we'll move on to the next question. So in this question, a coordinate frame have composite rotation of yaw pitch roll by 30 degree, 45 degree, 60 degree respectively. Find the resulting composite rotation matrix. So the composite rotation matrix will be R1 theta, R2 phi, and R3 psi into the identity matrix. So this R1 theta is because of roll, this is because of pitch, and this is because of yaw. Better take the same notation as I have in the previous slide. Gamma, beta, and alpha. Okay. So that it won't create confusion. So here the roll is 60 degree. So for this is along the x-axis. So this term will be 1. This another term will be 0, 0. And this will be cos 60 degree. That will become 1 by 2. And this is the first term. So minus 1 to the power of 1. This is about the first axis. So minus 1 to the power of 1 of sine 60 degree. So it will become minus of sine gamma. So minus of sine 60 degree is minus of root 3 by 2. This will become root 3 by 2. Now pitch is about 45 degree. So here it will be, and for 45 degree, that is 1 by root 2 for sine and cos both. And for yaw, it will be, how much it is? 30 degree. So cos 30 degree will become root 3 by 2. So when you multiply all this, you will get the rotation matrix R. You can multiply first these two, after that the product of this and this, and multiplying with identity matrix will give the same result. So you can do this, you will get the rotation matrix R. Okay, so in this, any doubt? And also, like in the lecture, there is one confusion created. In the lecture, what I have seen, sir has taken this F1, F2, and F3. He has taken the rotation along the first axis as, I think he has taken this F1 as, mm, this is the correct one. He has taken this, the rotation along this axis as rho. He has taken this as the first axis. So in our case, the first axis is here x. So don't get confused. This is our x, y, and z is coming up. Okay. So just a confusion is created, but generally the rotation along x-axis is taken as roll, and rotation along y-axis is taken as pitch, and rotation along z-axis is taken as yaw. So maybe the answer may come different as in the answers of NPTEL portal. So take care accordingly while solving. Okay, any doubt in this question? So now coming to the next question. So in this question, it is given the robotic arm fixed to the ground performs a composite rotation on an object by yaw of pi radians, roll of pi by 2 radians, and pitch of pi by 4 radians in that order with respect to the ground. A position sensor attached to the wall determine the position of the tip of the object after the rotation with respect to ground frame to be 548 units. Find the position of tip of the object with respect to its own frame of reference. So first we will find the rotation matrix as given with roll pitch yaw here. The first it is like the order is first yaw of pi radians. So the rotation matrix will be yaw of pi. After that roll of pi by 2, and after that pitch of pi by 4. So when you write R, take the first term as 1 and 0, 0. And here cos pi will be minus 1 and sin pi will be 0. Now for roll of pi by 2, it will become The role of pi by 2 here, it will become cos pi by 2, it will become 0, and then it will become 1 minus 1. And pitch of pi by 4, one more thing here. Like when we write yaw matrix, roll matrix and pitch matrix, we will follow this. Like here, how we have written the transformation. Like here, this is for the yaw matrix. This term is taken as 1 because it is with respect to the z axis. This with respect to the y axis for the pitch, and for roll this 1. So for pitch here, it will be the middle term will be 1, and this will become 1 by root 2, 1 by root 2, and then minus 1 by root 2. And for roll, this term will become 1, and here cos pi by 2 will become 0. This will become minus 1 and 1. This 2 will become 0. For yaw pi, sorry, cos of pi will become minus 1, 0 and 0. So when you do this multiplication, you will get 1 by root 2, 1 by root 2, 0, 0, and this will become 0, 0. So the R you will get here. So this is the R, and the position here, what they are asking, position sensor attached to the wire determine the position of tip of the object after the rotation with respect to ground frame is 548. So with respect to fixed frame, the position is, that is the ground frame, is 548. Now they are asking the position with respect to the on frame, that is the moving frame. So PF is equal to R into PM. So when you do multiply with R inverse, you will get R inverse of PF is equal to PM. And PM is equal to, here, this is orthonormal matrix. So R inverse is equal to R transpose into PF. So you can do this, the transpose of this, and then you multiply with PF. But in this case, when I have solved, I have not got the answer exactly, because in this NPTEL, in the question they have exchanged the role and yaw here, because they have taken, like what I am doing, I am taking this as a z axis, but they are taking this as a f1, and rotation along this they are taking as role, but the rotation along this z I am taking as yaw. So answer you will not get. For getting the answer, what you have to do, for getting the answer, you take this matrix as the first matrix, because the rotation along the z-axis they are taking as the first matrix, like this is the f1. For getting answer, you can do 1, and here this you take as a third matrix. This is just for getting answer, but I don't know, this confusion is created as sir have taken this axis as the first axis and rotation along this as a yaw. So when you take this in place of this, you take this answer, you will get correctly. But when you do the basic definition of roll pitch yaw, answer you will get differently. So any doubt in this? So I will solve, like we can solve how it is taken in the assignment of the NPTEL. So let's erase here so that confusion will not be created. I will write here answer won't match, because if someone want, like, see these slides, then they should not get confused. Because of this only the confusion has created. Okay, in the NPTEL lecture, the sir has taken the first axis of fixed frame is what we take as z axis. So that we are taking as yaw, and sir has taken this as a f3, this as a f1, and in actual this is our x axis. So I will write it clearly, like what is the confusion created here. Sir has taken f2, f1, f2, f3, and what we have taken is x, y, and z. So for this f1, this is roll, and for this, I'll write in the same colored pen. For f3, this is yaw. But for us, this is roll because rotation along the x-axis, and this is yaw. So just a confusion is created. But most of the time, what I am teaching the tutorial session, that only you will see. So according to NPTEL portal, we'll solve this question. So the R is equal to pitch of pi by 4, roll of pi by 2, and yaw of pi. So the pitch of pi by 4 is 1 by root 2, 0, 1 by root 2. Roll of pi by 2. See here in the NPTEL, roll is the first axis. So roll pitch yaw. So our is x. Sorry, both are taking this as a yaw only. Even I got confused when I studied. That's why I'm clearing it. So this roll is the third axis here because see this is x3. So here the roll is the third axis. So sir has taken this as a 1 at the third place. And after that pi by 2, so it will be 0, 0. Sine pi by 2 is minus 1. The minus sine pi by 2 and sine pi by 2 is 1. And yaw of pi, that is the first axis, that is 1, 0, 0, 0, minus 1, 0. And this cos pi is again minus 1. And this sine pi is 0. Now when you multiply, you will get 0 minus 1 by root 2. 1 by root 2 here. This will become 1, 0, 0, 0, 0, 0, 1 by root 2. This 2 term will become, this will become 1 by root. Now you multiply 1, 0, 0, 0, minus 1, 0, 0, 0, minus 1. So R here we will get 0, 1 by root 2, minus 1 by root 2, because minus 1 into 1 by root 2, here it will become 1, 0, 0, 0, minus 1 by root 2, and the third column is 1 by root 2 minus 1, minus 1 by root. So we have got R as this. Now we have to find the position in the moving frame. Like here you can see, position in the fixed frame is given, that is equal to 548, and position in the fixed frame is equal to rotational matrix into position in the moving frame. So now multiply with R inverse both the side, you will get position in the moving frame, that is equal to R inverse of position in the fixed frame. So R inverse is RT for this rotational matrix, as we have already discussed above. So the position in the moving frame is equal to, transpose of this will become 0, 1, 0, 1 by root 2, 0, minus 1 by root 2, minus 1 by root 2, 0, minus 1 by root 2. And position in the fixed frame is 548. So after multiplication, we will get 4, 5 by root 2, minus 8 by root 2, minus 3 by root 2, and this will become minus 13 by root 2. So the correct option is 4, and the second is our minus 3 by root 2, that will become around minus 3 by 1.4. It will be around something around minus 2, and this will become something around minus 9 point something. So the correct option is option D. Okay, any doubt in this?
Sir, while solving problem 666, it says roll on wires.
Like while solving the assignment, you use this, because in the tutorials, in the lecture session, sir has taken F1 as yaw, and F3 as roll, and F2 as pitch.
So
In,
in the exam,
in exam also you solve like this, how we have solved in this NPTEL. Or you can ask this doubt as there is a forum, no? You can ask this as a doubt there.
hmm.
Actually, from NPTEL, if someone clears this, then that will be better. But for now, the solution we are getting for the NPTEL question, if you solve like this. In this method, we are getting the wrong solution.
So you are telling to follow NPTEL only.
For NPTEL exam and NPTEL solution
Oh,
for assignments.
oh, oh.
And also you can post this as a doubt that rotation along z-axis is yaw. Then like you can post this as a doubt in the forum.
Yes.
They will clear it. So now we will move on to the next question.
But the correct is X is roll and Y is pitch and Z is yeah, no,
Yeah, yeah.
rotation.
Huh.
Okay.
That is the standard notation what is used in all the robotics.
Yes, yes.
Here also it is same thing only, but sir has fixed F1 as yaw, and that F1 we are taking as a z-axis always. So the confusion came like that. So for his F1 is yaw, so whenever he takes yaw, he takes the first element as 1 here. But in actually yaw is rotation due to the z-axis, so we should take 1 here. So that's why in the standard notation we are getting the wrong answer. It's not the wrong solution, actually we are getting just wrong answer. This is the standard notation. Like a standard notation, I have already attached a slide so that the confusion can be removed. So this is the standard one, what you see here. Like even if you solve using this formula like cos alpha cos beta, you will not get the solution on the NPTEL assignment because in this the alpha and gamma is reversed, something like that. So moving on to the next question. So here the homogeneous transformation matrix is given. So whenever it is given, just draw like this. This is our rotation matrix. This is our translation matrix. Okay. Now it is asking which statements are the true statements. So the x-axis of the fixed frame and that of mobile frame along the same direction. So here you can take this. The rotation matrix you can write from this minus 1, 0, 0, 0, 1, 0, 0, 0, minus 1. And for the fixed frame, R is equal to identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So now you can match here. So this is minus 1, this is 1. So x-axis is rotated 180-degree from the fixed frame. This is 1, this is 1. Y-axis rotation is 0 and this is again rotated 180-degree. Okay. And the translation in XYZ is 2 to 1. Translation in X, Y, Z is 2 to 1. So now we see all the options. The axis of the fixed frame and that of mobile frame are along the same direction. No, because it is along the opposite direction because it rotated at the 180 degree. So this is the wrong option. The y-axis of the fixed frame and that of mobile frame are along the same direction. Yes, these are along the same direction. So option B is correct. The origin of the fixed and mobile frame coincide? No, because along with rotation, it is translated also. Okay, rotation and translation both are done here. So the axis, the origin will not coincide. So this is wrong option. The z-axis of the fixed frame and that of mobile frames are anti-parallel. Yes, anti-parallel means opposite direction. So here you can see rotated by 180 degrees. So this is the z-axis of the fixed frame and this is the z-axis of the mobile frame. ZM, ZF. So this option is correct. Now the last option, if the position vector of point in mobile frame is 0.521, then its position vector in fixed frame will be 0.540. So we need to solve this. So the transformation matrix is, no, first we will write, directly we will solve. The position in fixed frame is transformation matrix into position in the mobile frame. So position in fixed frame is 0.540 and transformation matrix is minus 1, 0, 0, 0, 1, 0, 0, 0, minus 1, 2, 2, 1. And position in the mobile frame is 0.521. So you take one more extra one, that is a scaling factor here. So now we have to match like the position in this or this is matching or not. Actually, this we cannot, if for doing equality here, you have to add 1 here also because that is a 4 cross 1 matrix. And this is our x, y, and z, and this is a scaling factor sigma. Okay. Here also this is scaling factor sigma, so that you can ignore while after calculating the position. So when we do the multiplication, we will get minus 0.5 plus 2, that is 1.5 minus 0.5. Okay. Now the second term is 2 plus 2, that is 4. The third is minus 1 plus 1, that is 0. And the fourth is 1. So in the mobile frame, the position is 1.5, 4, and 0. And the fixed frame, the position is 0.541. So this is not equal, LHS is not equal to RHS. So these two options are only the correct option. Okay. 0.52, one was in the mobile frame and fixed frame it was 1.5. Sorry, here it was 1.540. Okay, both are same. Sorry, because here it is it's 0.5. Maybe the question was okay. This is 0.5, then the option is wrong because that is not equal. So this option is wrong. So now coming to the next question. Do you have any doubt in the previous question? Okay, so in this question, any comment in the chat box? Okay, fine. Just wait for a minute. Hmm. So in this question, it is given two frame A and B are initially coincident. Frame B undergoes the following four motions in sequence with respect to its own axis. So frame B is rotated and translated with respect to its own axis, not with respect to the A. So these are the four operations happened. Rotation of theta degree about z axis, translation of d units about the z axis, all are with respect to frame B only. So it is written with respect to its own axis. A translation of A unit along with x-axis and rotation of alpha degree about the x-axis. Determine the final homogeneous transformation matrix to describe the pose of frame B with respect to the frame A, and let theta d a and alpha that is given here, theta d a and alpha, the units are 30 degree, 20 units, 5 units and 60 degree. What will be the final position of B with respect to frame A? Okay, so in this question just asking the final position of B with respect to the frame A. So first we will see all those translation. Here you can see, let's suppose our fixed frame is F1, F2, F3. This is our moving frame, M1, M2, M3. Like F2 and F3 is in the plane of the paper, and F1 is coming out. Same M1 is coming out. So first, A part is a rotation of theta degree about Z axis. Okay. So after A, it will become about the Z axis. So Z axis, this M1 that is coming out of the paper will remain same. It is rotated, theta is equal to 30 degree. So 30 degree this side. This is our theta. Okay. And this is M2 and this is M. Now, in the second part, it is saying a translation of B units about the Z axis. Okay. The first part was a rotation of theta degree about the Z axis. Okay. The next part is translation about the Z axis, and how much, that is 20 units. So it will come here. The origin will shift up. So this is our M1, M2, sorry, this is M2, this is M1, this is M3. And this unit is 20 unit. Okay. Now in the third it is saying translation of A, translation of A unit along the x-axis. Now it is 5 unit displaced along the x-axis. So somewhere origin will shift here. Because see, this is the x-axis, x-axis of moving frame. It will shift 5 unit in this direction. So let's suppose this is the 5 unit. So the center will shift here. And again after that rotation is happening 60 degree about the x-axis. So here only about the x-axis rotation is happening. So the x-axis will remain same like this, and the rotation will go x. If you rotate along x-axis, then this will rotate like this. So this will rotate 60 degree and this will rotate 60 degree. Something it's happening like this, you can imagine. And now they are asking what will be the final position of B with respect to the frame A. So the final position of B with respect to frame A. So this is our origin 0. So in this directly we can take as the value of, like uh, uh, it is like translated along 5 units. So we can take 5 cos 30 degree. I will just make a simple figure. Just wait for a second. I will take, let's take this axis as a z axis, then we can easily visualize it. M3 is z axis, M1 is x axis. Sorry, M2 let's take x, and this you take as a y. So we'll do fastly now. Now the first is rotation along the z axis. So let's suppose this F3 is z. So you just rotate 30 degree along the z axis in the, like let's suppose this is the rotation. This is our z axis. So this is 30 degree rotation. Now in the next what we have to do, translation of d units along the z axis. So this is our z axis. So here just translate it by 20 units. Now we can easily visualize. So this is our 20 unit. 20. Okay. And after that, it is saying translation of a unit along the x-axis, and this is our x. So after that, the same thing will move 5 unit rightward. So from here, it will displace here. So now this is 20 and this is 5. Okay. And after that, along the x-axis, it is rotated 60 degree. So this is here z, this is x, this is y. So along the x-axis, it is rotated by 60 degree. So this x will be same here, and this z will rotate by 60 degree, and this y will also rotate by 60 degree. So now it is asking the distance between these two this along the x-axis. Okay. So this will become 5 into cos of theta. When you project this will become 5 of cos theta. So that will be 5 into cos of 30 degree. So directly you can write here 5 into cos of 30 degree. When you do this projection, you will get like this. Any doubt in this? Like this is little complex. Like I have tried to visualize all those four transformation.
Sir,
What happened?
this Z 60 degree has to be in the anti-clockwise direction, sir. 60 degree.
Where?
This, this is your drawn as well.
Hmm.
60 degree along the x-axis.
Hmm.
Then this Z has to be rotated on anti-clockwise. Y also has to be rotated anti-clockwise. No?
Yeah, yeah.
60.
It should rotate by 60 degree anti-clockwise. You were right. And here also I have taken clockwise. So this
No, sir.
also,
All you have taken anti-clockwise.
no, this also I have taken a clockwise rotation, 30 degree. Okay, that also I need to change
No, 30 degree you have taken anti-clockwise. Sir.
along the
Yeah.
z axis.
Yeah, clock.
Clockwise only I have taken.
Oh, yeah. Okay.
So we can just do little modification. Thank you for suggesting. This is 30 degree. So simply you do just 5 cos 30 degree. The answer will be in x unit, that you will get 5 into root 3 by 2. So that you will get 5 into around root 3 by 2 will be 0.866. So you will get around 4.3 unit. Now this is the same question what we have solved before. Previously you can solve. R is equal to, you can do this, this is rotation in yaw, pitch and roll, 90 degree, 45 degree and 60 degree. So you can just multiply. Here roll is 60 degree, so cos 60 degree you will get as 1 by 2. Cos 90 degree is 0. So you do this, you will get this rotation matrix R. The answer might not match because of that. You, if does not match, then you follow this method of roll PGO and then you will get the answer. And also, like, I will talk about this, like the application of this in real robotics. Like, most of the people nowadays, like most of the researchers are working on the autonomous vehicle field. So in that, let's suppose take a two sensors, that is LiDAR and camera. So LiDAR measure in the world frame here, that is W, U and V. Camera basically first measure in pixel UV. So after the pixel coordinate, it is transformed into image film, that is in the X and Y coordinate. And after that, it is transformed into camera coordinates of X, Y, Z. And then these two coordinates are transformed together to fuse the LiDAR and camera data. Here you can see pixel coordinate is first transformed into film coordinate in X and Y. And after that, camera coordinate into X, Y, Z, and then into world coordinate. So this is our world coordinate. This is a good research area like camera LiDAR sensor fusion. So I'm just giving the brief introduction. You can read on the internet. You will get too much resources on this. This is our pixel value in the image. Now, how this pixel can be transformed into world coordinate using this intrinsic matrix, that is denoted by M int, and extrinsic matrix. So here you can see this extrinsic matrix. Here this is the rotation matrix and this is the translation matrix. So here is the use of rotational and translational matrix what we have studied. So using this we can convert the point cloud from LiDAR from the world coordinate to the camera coordinate. So these things you might not get now, like point cloud and all. So you can see this slide, I will upload on that and you can refer to some of the internet sources. And here that is the rotation and translation in the 2D. You can easily understand here, like if you rotate and translate in 2D. So these things you can study from the slide. So today we'll close the lecture here only. If you have any doubt, then you can ask now. And also you can ask on the YouTube video in the comment section. These videos will be uploaded on the YouTube.
So 3 days, 2 days there was meeting process, same thing you have discussed, sir.
Yeah, actually the questions given in the previous year assignments that are same, but I have tried to add many things new, like some of
And
the
28, 30, 31st was very sir.
yeah, yeah, two more TAs are there. So I have tried to add more questions, like these questions are new from that. But anyway, we'll try to add more new questions from my side. I have tried to add 8 to 9 new questions from my side from the
What's
net.
the difference from this one, sir?
Yeah, these questions are different, and even these concepts of slides and all. I have added some extra slides, what
Oh,
they have done.
sir, when again we will be having live sessions?
Like you will be having three live sessions, one on Saturday, one on Sunday, and my live session will be on Tuesday.
Okay. Is this fixed for every
Yeah, yeah,
class, sir?
yeah, yeah. 7 to 9 weekly once on Tuesday. Mine classes are fixed. For other TS timings, I don't remember, but it is on Saturday and Sunday.
Okay, thanks. Thanks.
Okay, thank you.
Sir, is it slides available in your website? Will be available in next session.
Yeah, we will upload on the Google Docs or Google Drive, and the link of the Google Drive will be uploaded in the NPTEL portal of the
Thank you.
on the course portal.
So thank you for your time.
Oh, welcome. So if there is no doubt, then we can end the first tutorial session here only. Thank you everyone for attending. We'll meet again on Tuesday from 7 to 9 p.m. Thank you.
Thank you.